Hello, my name is Zulaika binti Khalid and I'm going to explain on elastic shortening. Elastic shortening is the loss of prestress that happens when the concrete shortens after the prestressing force is applied. How it works. When the prestressing force is transferred to the concrete, the compressive stress causes it to shorten elastically. Since the tendons are bonded to the concrete, they also shorten, which reduces their tension and leads to a loss of prestress. There are two types of condition under elastic shortening. In pre-tensioning, the tendons are tensioned first and then the concrete is poured around them. Once the concrete hardens and the force is transferred, the concrete shortens and the shortening causes a reduction in tendon stress. The process can be summarized in three stages. Tendons are tensioned, concrete is poured, and elastic shortening occurs. In post-tensioning, if there's only one tendon, there's no elastic shortening loss because the shortening happens before the tendon is anchored. However, in members with multiple tendons, the first tendons to be stressed lose some tension when the later tendons are tensioned due to the overall shortening of the concrete. This results in a redistribution of losses among all tendons. Overall, elastic shortening is an important factor in prestressed concrete design as it directly affects the efficiency and long-term performance of the structure.
Hello, my name is Isafi. Now let's take a look at one of the most important immediate loss in prestressed concrete, the loss due to friction. This type of loss happen mainly in the post-tension system where steel tendons are placed inside ducts or sheds that run through the concrete member. When the tendon is stressed, it tends to move along the duct, but the friction between the two surfaces resists this motion. Because of this resistance, the pre-stress force decreases gradually from the jacking end towards the far end of the tendon. This means the pre-stressing force is not uniform along the member. It's highest near the jack and lowest near the anchorage. There are two main sources of this frictional loss. The first one is the wobble effect, which is caused by unintentional deviation in the alignment of the duct. Even in a straight duct, small irregularities during construction can cause angular displacement that create resistance. This effect is represented by the wobble coefficient denoted by K. The second one is the curvature effect, which occurs in tendons that are intentionally curved to provide an upward balancing moment. Friction here is proportional to the angle of curvature, represented by theta, and depends on the coefficient of friction mu. To minimize this loss, engineers often stress the tendons from both ends or apply a slightly higher jacking force at one end to compensate for the reduction. Now, let's take a look at the formula used to calculate the percentages loss of pre-stress due to friction. The formula is given as percent loss equals to the 1 minus exponent to the power of negative mu theta plus kx multiplied by 100. In practical terms, higher mu theta or k means more friction and higher loss. Longer cable with larger x value also experience greater cumulative loss. For a straight tendon, theta equals to the 0, so only the wobble effect contributes. But for the curve profile, both factors work together and the loss can be a few percent, between 1 to 3%. So this formula helps engineers estimate how much of the pre-stressing force is actually lost due to the friction, allowing us to adjust the design or stressing procedure accordingly. For example, by stressing from both ends or slightly over tensioning to compensate.
Hi, my name is Mohammed Hafiz, so for the third losses on immediate is anchorage slip. So what is anchorage slip? First, anchorage slip is an immediate pre-stress loss that occurs in post-tension concrete systems during the transfer of force from the jack to the anchorage. Second, when the jack releases the tendon, friction wedge slips slightly before fully gripping the tendon, causing a shortening of the tendon. Third, the anchorage block may also move slightly before settling against the concrete, contributing to additional loss. Fourth, the slip result in a reduction of the effective pre-stresses force, which can affect the structural to additional loss. And the last one is anchorage slip is not present in pre-tensioning systems, as tendons are bonded to concrete before anchorage is applied. Next, how it has happened and how to calculate it. The loss of stress due to anchorage slip is caused by a small physical movement of the tendon during anchoring. Next, this movement leads to a shortening of the tendon, reducing the force it can apply to the concrete. By using the formula P equals A L, we can see that the loss for 30 meters beam is 3.5%. Therefore for 3 meters beam it is 35%. Thus we can conclude that the anchorage slip has a greater impact on shorter members, making it a critical in design and site execution. For the last slide is, what factor influence magnitude of anchorage slip loss? First, the amount of slip and resulting stress loss depends on several factors, like type of wedge used in the anchorage system, then stress level in the tendon during transfer. Next, length of the member. Shorter member experience higher percentage loss. Second factor is site practice to minimize anchorage slip loss, like overextension of tendons before anchoring to compensate for expected slip. Use of tested and certified anchorage systems with known slip values. The last one is, proper control of anchorage slip is essential for ensuring design compliance, maintaining structural integrity, and supporting quality assurance and academic reporting.
It's Macquarie Alcini Anak Matthias, and I will explain about creep in concrete. Creep is time-dependent deformation of a material under sustained constant stress or load. Creep occurs because of over a long period, even if the applied load does not change. So it is because of a movement of water that out of the cement phase and also micro-cracking. First, the effect on beam. The first effect on beam is increase in deflection, which is it can affect the serviceability of the structure. Next is a loss of prestress. Creep in the concrete causes the concrete to shorten, which is to reduce the tension in the concrete. And then last but not least, the effect on a beam is stress redistribution, which means creep tends to transfer the compressive stress which is from the concrete to the steel reinforcement. Next, we move to the factor that affecting the creep in the concrete. At first, which is age of concrete at loading, meaning by that the concrete was loaded at a very young age. Next, the water-cement ratio. It shows that the higher water-cement ratio, the greater creep will occur in the concrete. Next factor is humidity and temperature, where as we know that the lower humidity and higher temperature can increase the rate of the creep because it getting drier and for a long term time it will cause a higher rate of creep. And last but not least about the factor that affecting the creep, which is the concrete mix and also the aggregate. It depends on the type of material that we will use, and the higher modulus aggregate will also can reduce the creep.
Hi, my name is Muhammad Akil Zohair. So, for the second losses for time dependent is shrinkage. Shrinkage. What is shrinkage? Shrinkage is the gradual reduction in volume or strength of concrete over time when it's not under any load and the temperature stay constant. What are the factors why shrinkage happen? It happen mainly because water inside the concrete evaporates or gets used in the chemical reaction, which is hydration. Shrinkage and creep also has the same factors that cause it happen, like humidity, temperature, mixed proportion, and age of concrete. So, but creep happen because it happen need loading, while shrinkage occurs without any load. Also, shrinkage strength can be considered depends on 5 things, which is aggregate use, effective age at the transfer, relative humidity, effective section thickness, and lastly, original water content. So there are 2 typical values for the shrinkage losses, which is first we can get from the pre-tension concrete, which is why? Because shrinkage strain are usually range from 230 times 10 to the power of negative 6 to 550 times 10 to the power of negative 6. These are usually the range values for the shrinkage strain. This also means that concrete shrinks more in dry conditions because there is less moisture in the air. And next is we can get from the theoretical calculation from the loss of stress in the steel. So the formula is given, which is we can get from the formula loss in prestress force, which is equal to epsilon CS times ES times AP, which is epsilon CS is shrinkage strength of concrete, ES is modulus of elasticity of steel, and AP is area of prestressing steel. The last pre-stress losses from the time dependent is steel relaxation. So, why steel relaxation? Steel relaxation is the reduction in stress with time at constant strain. It decrease in stress is due to the fact that some of the initial elastic strain is transformed into inelastic strain under constant strain. So the stress decreases according to the remaining elastic strain. According the 3.3.2.7 of Eurocode, using 1000 hour relaxation, usually is about 70% of characteristic strength, and also losses about 4 to 10% of pre-stress force after transfer. What are the factors affecting relaxation? First, time. Second is initial stress. The third is type of steel, and lastly is temperature.